Our meeting will begin in 10 minutes. Please take your seats. Our meeting will begin in 5 minutes. Please take your seats. Please take your seats. As a courtesy, we ask that you place all wireless devices on silent. Our meeting is about to begin. Please take your seats.
performance. It's what separates the winners from the rest. Those who perform at the highest level are the ones who make history and shatter the status quo. But what is the key to better performance? What makes a product smarter, faster, stronger, more reliable? The answer lies in your test data. By tapping into the vast power of test data and advanced analytics, NI helps you discover insights that supercharge the quality of your products and drive countless efficiencies across your organization. Less downtime, fewer defects, greater scalability. Some might say it's a bold concept, rethinking test as a way to boost the performance of today's complex products and the businesses that create them. We simply see it as another way NI is committed to engineering your success.
Ladies and gentlemen, please welcome to the stage NI CEO Eric Starkloff.
All right. Woo. It's good to be back, isn't it? Yeah. All right. Whew. It is fantastic. Welcome to NI Connect 2022. Boy, it has been a strange couple of years, and one of the things I think we've missed the most is connections. These sort of deep, authentic connections between people, and it's thrilling to be in front of so many of you in person here today, and I also want to welcome the thousands of people that are online, joining from around the world. So let's make some new connections over the next 2 days. So I'm going to start off this morning with a little story, tell you a story about data and performance. So for 100 years, the British cycling team was exceptionally mediocre. They went nearly a century, and they got 1 gold medal in the Olympics, and they had 0 Tour de France victories. I mean, it was bad. The only thing that was consistent about the team was that they lost over and over and over again. Sorry for the Brits in the room. It got so bad at one point that several equipment manufacturers refused to sell to them because they didn't want to be associated with such a terrible team. But then, in 2003, everything changed. See, that year they brought on a new performance director, a guy named Dave Brailsford. And Brailsford had this simple but really innovative idea. His idea was that if they could analyze and measure everything that it takes to be a high-performance cycling team, they could improve each step, bit by bit. 0.5% improvement here, 1% improvement there, and that those improvements would add up to something much bigger. Now, to execute his plan, Brailsford needed data. He wanted data from every part of the process. And so they outfitted the cyclists with biofeedback sensors to assess their riding technique. They tested things in wind tunnels to make sure, for example, the fabrics, they used the most aerodynamic type of fabric. And as they made all of these measurements and started to improve, the team began to improve. But they didn't just improve, they dominated. In 2008 in Beijing, the British cycling team won 8 of 14 gold medals. And then in 2012 in London, they did even better, and they set 9 Olympic records. They went through a 6-year period where they won the Tour de France 5 times. And this incredible turnaround was owed in part to this idea of using data and measurements to improve every step of the process. Now you can see where I'm going with this probably, right? There's an opportunity for us to learn from this example and apply that lesson to the work that we all do. Because certainly everyone here, you want to increase performance, right? You want products that perform better, you want them to be more reliable, and you want to get to market faster than ever before. And to do that, we can follow this example of the British cycling team. We can improve our businesses by collecting and using our test data, Because test data is so crucial, it's the only data that tells you how your product actually performs in the real world. Now, the key to doing this is to first automate through software. That's the first step, to get and collect this data. And once you do that, you can use that data to start to create that iterative loop, to start to improve. And once you have that virtuous cycle, you can apply clever algorithms like artificial intelligence and machine learning to actually improve, make that loop smarter, and make it more automated. Of course, software and automation is core to what we do at NI. It's in our DNA. Many of you have, for decades, been using our software and software-connected systems to adapt and collect data from your products and ensure their quality. Tools like LabVIEW and TestStand and SystemLink have enabled you to take advantage of data and build better products. And this is particularly important in the fastest moving technologies that many of you are working on. Technologies like autonomous and electric vehicles, like high-performance RF semiconductors, or like new space technologies. And these same techniques are going to be required by more and more applications in the future. So this afternoon in the keynote stage, we're going to talk about our perspective of how test will evolve in the future, how it'll be part of a more connected design flow, how we'll fully utilize leading-edge technologies like the cloud, and how we'll achieve hyper-automation through AI and ML. We're going to share this vision, and we're also going to share the investments that we're making to turn that vision into a reality. Now, we're also keenly aware that you are solving mission-critical applications here and now. And your pressure to deliver has certainly never been greater. So this morning, we're going to show you how some of the leading companies in the world are innovating their test processes and their use of test data to improve performance today. I couldn't think of a better place to start than in the automotive industry. Talk about an industry that has undergone transformative change. Our cars have changed more in the last few years than in the 100 years they've been on the road. Personally, I've been fortunate to have sort of a front row seat to some of this innovation. As a vendor and partner to companies across the automotive supply chain, and also as a consumer. I jumped on the EV bandwagon back in 2015, and I'm on my third electric vehicle. I've been able to see firsthand the advantages of the technology and also how quickly it's changed and evolved over the last few years. Now, GM is a company that is betting their future on EVs and implementing that technology at tremendous scale. So to tell us more about that, I'm going to welcome to the stage from GM, their Director of Global Battery Cell Engineering, Steve Tarnowsky. Steve.
Hello, Eric. Good morning.
Welcome, Steve. Thank you for joining us.
Thank you. It's great to be here.
So GM has taken, I mean, everyone's seen this big public pivot. Your CEO, Mary Barra, has made some incredible pronouncements. She's talked about Vision Zero for the company. But you're in battery cell engineering, and so a big part of your job is how do you turn that vision into a reality? And we're going to talk about that here this morning. But let's start with the vision. Talk about GM's vision for an all-electric future.
Sure, Eric. So sticking with the theme of making connections, at General Motors, we pioneer the innovations that connect people and move people to what really matters. And we envision a world with zero crashes, zero emissions, and zero congestion. And that's our highest aspiration. So, from becoming carbon neutral as a company by 2040 to making all of our new light-duty vehicles fully electric by 2035, we're redefining how people and goods are moved. And we have plans to capacitize for more than 1 million electric vehicles in North America per year by 2025. So innovation speed is driving us to take serious steps in the way we operate at a global level. So from repurposing manufacturing footprint to building new battery labs and cell plants, we need to scale in multiple dimensions, and that we need to do that, the need is greater than ever. So to redefine the future of mobility, we're growing beyond vehicle manufacturing to becoming a platform innovator.
Yeah, so this always reminds me, we have this expression, engineer ambitiously. People probably noticed it around the conference. The idea here is you have this bold vision and the engineering that it takes to turn it into a practical reality. And you know, that's exactly what you're doing. I mentioned I'm kind of an EV enthusiast, and I shared with Steve that a couple of weeks ago, I was kind of found myself in a rabbit hole in the internet, and I was researching about the EV1, one of the first electric vehicles back in 1997 that GM created. There it is. Some of you remember that. And what was amazing about that car was that so many of the elements of a modern electric vehicle were in that car back in 1997. It's really extraordinary. But the one challenge was really around the batteries. It had lead-acid batteries, are pretty big and heavy, and its range was kind of 70 miles at best, and that made it very difficult to be a commercial success. So the point there is that it's all about the battery. Like, the battery is such a critical defining element of the vision. So how are you dealing with the challenge to produce those at scale?
Yes, it is all about the battery. Making batteries at scale is going to be key to being successful. And by the way, I did have the privilege of working on the EV1 propulsion system, validation, and also the inductive charging system more than 3 decades ago.
So cool.
So now getting back to today, I want to talk a little bit about Ultium. So Ultium is the name that we've given to our all-electric vehicle architecture and propulsion platform. And it consists of modular and scalable building blocks for our all-electric future. Now, these building blocks include families of drive units, motors, power electronics, controls, and then, of course, at the heart of Ultium is the battery. So Ultium enables not only the transition of today's retail lineup to EVs, but offers even more choice and life-changing benefits of electrification to our customers. Now, we're already seeing the Ultium effect in the GMC Hummer pickup and the Cadillac Lyriq, which goes on sale shortly. So imagine the scalability benefits of being able to build an extreme off-road truck like the Hummer, a luxury compact utility vehicle like the Lyriq, and even a commercial delivery vehicle like the BrightDrop EV600 from a common set of components. So by consolidating on a platform like this, our customers will have more vehicle choices with better driving experience. And then, of course, our engineers and designers will have more opportunities to be more creative, given less constraints from traditional large powertrain systems. So for all of this to come to fruition, there's a fundamental need to harness insights from that propulsion battery data.
Yeah, by the way, that platform approach is something that's real resonant to us, that idea of common components that go into multiple applications. But let's talk about that harnessing insight from data, because it's kind of a theme of today and tomorrow, where tests can be not only kind of backward-looking to assess pass-fail, but also part of a forward-looking process to optimize performance. So in these battery labs, what's the data challenge, and how are you trying to solve it?
Sure, Eric. When you're building an EV platform like Ultium for such a wide variety of electric vehicles, at scale and at speed, many factors can impact battery performance. And there's just an unimaginable amount of data available to characterize that performance. So the Ultium architecture is flexible and scalable to enable battery packs with 8, 10, or 12 modules per vehicle. And this allows our customers to buy different size vehicles with different vehicle range that's right for their budget and needs. And the modular layout that we're showing here right now focuses on large pouch-style battery cells for markets including North America. And these can be stacked horizontally like pancakes or vertically like toast, depending on the form factor needs of each vehicle. Now, the cells are assembled in groups of 12 to 24 per module, then assembled into battery packs. And when more energy is needed, like in the Hummer pickup, we can actually stack an additional 12 modules on top of the first 12 modules for over 200 kilowatt hours of stored electrical energy.
Which is a lot.
It's a lot of energy.
Least,
yeah. So in addition to the pouch format, the Ultium platform enables a prismatic can cell format as well for the markets where this is preferred. And this allows us to optimize our global footprint, increase cell options going forward, and then when new technology and chemistry become available, we can adopt those technologies while still preserving the overall battery pack architecture. And this essentially future-proofs our platform in preparation for those expected chemistry advances. Now, it's probably no surprise that the battery has an outsized impact on cost and performance for the vehicle. So getting it right will be the turning point for massive EV adoption. Now, in this case, getting it right means we must ensure that everything performs at its best from the cell level all the way up to the pack level. Otherwise, critical problems can cascade. So consider the hundreds of cells per pack and then multiply that by millions of vehicles that are going to be produced each year. We must safeguard the quality of every cell in every pack. And we're working with NI on a data-driven approach to, number one, ensure that there's zero blind spots in our battery process of engineering, and two, enable battery performance optimization. Yep. So to have zero blind spots, we harness the power of that data from all the available sources. So we've got test labs, we've got control stations, supply chain, our manufacturing facilities, and even aggregated from our vehicle customers with their permission, of course. So massive amounts of data from the cell, the module, the pack, the testing, all the equipment. That's all required for us to optimize performance. And we use data insights from our product development to develop algorithms that we can then in turn communicate information to our vehicle customers to help them optimize the performance of their vehicle, like range and acceleration performance and even battery life. So we believe this makes our EVs even better and improves our customer ownership experience.
Yeah, very cool. By the way, the auto companies have the best marketing material, don't they? Those videos are awesome. Yeah, so, let's talk about then how we're working together. So you've been a lead user on our lifecycle analytics solution, and we've been working together, our teams have been working really closely together to build the software that you need for this battery analytics based on our NI System Link platform. So share about how we're working with NI to address the challenges you just shared, Steve.
Sure, so we're working with NI on a long-term sustainable solution that allows us to connect all the battery test data to quickly develop the insights that we need. Now, the solution must be secure, must be scalable, and it needs to be open. Now, let's start with security. So battery insights are clearly give us a significant competitive advantage and typically lead to intellectual property that has real value. So with NI's System Link, we can implement access control so the right people have access to the right data while securely storing that data. And it also allows different levels of authentication to be employed that ensure that only authorized users have access to that data with the right level of encryption. Now, with scalability, it's all about maximizing automation. So the end-to-end data ingestion process, aggregation of data, the processing, the analytics, the reporting, and even the sign-off procedures of collecting all this data from disparate sources, it's all automated. And this automation saves thousands of hours of manual work per project. And this also gives our engineers the flexibility and independence of having on-demand access to the needed data when they need it, and in a way that enables key decisions. And then finally, regarding openness, the system is built mostly on commercial off-the-shelf technology, so this allows our engineers to use open source systems, different databases and programming languages, and allows us to define the dashboards and customization that we need to analyze the data to get those insights to make those key decisions. So from NI, we're getting a solution that's fully compatible with GM's IT infrastructure. So it's no longer up to our test engineers to maintain, but we can leverage our IT professionals to make it sustainable, compliant, and completely vendor independent.
Working with IT is important. I know that resonates with lots of people. And look, this is a great example of this data-driven approach to improve performance. And I got to tell you, we are thrilled to work with GM on this important area for your business, but also an area with so much impact ultimately on the world.
It's great. First of all, I really appreciate having the time to come and talk about Ultium and how NI is helping us reduce risk, perform our engineering work more efficiently, and give us a faster time for those insights and decisions. So I appreciate the opportunity to speak this morning about Ultium and the role that NI will play in helping us achieve an all-electric future. So thank you.
Steve, thank you. Thank you so much. Appreciate it. Man, that is really, really cool. That's engineering ambitiously. Very, very cool application. So next up, we're going to talk about another area where technology is moving really fast, and it's challenging the way we design and test really complex systems, and in particular, necessitating the use of modeling integrated very tightly with real-world data. And that's the area of radar systems. So to help educate us on this challenge, we have a privilege to have a real expert on this from the U.S. Department of Defense. So please welcome AFRL Senior Advisor to Air Force Futures, Dr. Howard Meyer. Dr. Meyer, there he is. Yeah. So, Dr. Meyer, tell us about the challenges you're focused on at the Pentagon.
Okay, thank you very much. Good morning, and I want to express a sincere thanks to our host, NI, and also to you, Eric, for inviting me to participate in what is surely to be a great NI Connect event. I have the extreme privilege of serving as the Air Force Research Laboratory Senior Advisor to Air Force Futures, the headquarters U.S. Air Force organization responsible for developing the requirements and the force constructs for our nation's Air Force of the future. In saying this, I have to admit that representing an organization that employs over 11,000 people with a budget of over $7 billion is a significant challenge, but I'm enjoying it immensely. As a nation, we can no longer afford to spend decades developing the military capabilities that we need, both now and in the future. To significantly accelerate the development of these capabilities, digital engineering has become an essential. Digital engineering works. It's demonstrated great success at dramatically reducing both the time and the costs associated with developing new weapon systems, such as the Air Force's Next Generation Bomber and Next Generation Air Dominance Fighter. By employing the latest high-fidelity, physics-based modeling and simulation tools for aerodynamics and mission-essential systems, coupled with integrated CAD/CAM capabilities, digital engineering ensured that when prototypes were developed and fabricated, they performed as expected. Personally, I have a high interest in the electromagnetic spectrum. All military systems rely on RF and electro-optical sensors and communication systems. If we can't see to sense the operational space, and if we can't communicate to direct the actions of our forces, we've already lost. For these reasons, our communication systems must be significantly more robust and resilient. And our sensor systems must be capable of detecting and tracking fixed and moving targets at greater ranges, in all weather, in all operational environments and conditions, and including even when our adversaries employ deception against us. The complexity of the future electromagnetic spectrum battle space is going to increase significantly. The amount of useful RF spectrum will continue to decrease as all parties, friendly, adversary, and neutral, employ RF technologies for all reasons. Concurrently, the global proliferation of advanced electronics technologies is enabling our adversaries to develop and more effectively tools and more effectively contest our use of the electromagnetic spectrum battle space by hindering and denying our ability to see and communicate, and thus effectively employ our forces. This means that future military EMS systems will require enabling technologies and architectures and also commensurate test and evaluation capabilities to ensure the systems we're developing perform as advertised. Recall what I said about digital twins, and let's apply that to the EMS battle space. We must be able to instantiate operationally realistic digital twins into increasingly complex and realistic EMS environments to accelerate the development of the military capabilities that we need. We need this much because much of this work is either too costly or it's very, very difficult to impossible to replicate in open air test ranges. Now this brings me to a digital engineering environment, really a success story that was developed specifically for the Air Force for RF applications, including radar and electromagnetic warfare, RFView. Developed by Information Systems Laboratory with funding from AFRL under the Small Business Innovation Research Program, RFView enables digital twinning of any advanced RF system operating anywhere in the world under whatever operational conditions we require. Of equal importance, we need the ability to develop to employ real-time flight hardware and hardware in the loop interfaces in these virtual environments. And ISL did this for us with RFView using NI transceiver technology. All of this means that we need you, each of you present today and listening, the developers of these remarkable technologies that our nation is so critically reliant upon. We need you to continue their advancement so we, the Air Force and the Department of Defense, can continue to develop, explore, test, and validate the EMS capabilities our nation needs to ensure all people everywhere can continue to enjoy the freedoms we all treasure. Thank you, Eric, for inviting me and giving me this opportunity to share these needs. And I want to thank each one of you, the developers of these truly amazing technologies, for listening to me today. Your work is difficult and challenging, but it's essential.
Dr. Meyer, thank you so much. Appreciate it.
Thank you very much. It's an opportunity.
All right, thank you. Thank you.
Thank you.
We're proud. Yeah, thank you. We're certainly proud to be part of the technology that enables such an important application, and we want to show it to you. So just to put this in perspective, he talked about digital twins, and some of you are probably familiar with that application in different areas. One of the areas you might be familiar with is like testing an autonomous vehicle, where you simulate, the city block for maybe the real control hardware of the vehicle you'll hardware in the loop testing. But here, the challenge is you have a battlefield that's thousands of miles across. You have countless different devices, and some of them are actually adversarial. So it's a super challenging application. So we want to take a look at it so you can see it demonstrated. So to give us a sneak peek at RFView, please welcome Hayden Nelson from NI and Dave Kirk from Information Systems Laboratories.
How you doing, sir?
Hey, Dave.
All right. Kick us off. Thank you, Eric, and thank you, Dr. Meyer. I appreciate that explanation of the electromagnetic spectrum and how important it is, to operations, and how test and data is going to play a critical role to fielding advanced radar and EW capabilities faster. So, Dave, we got a copy of RFView up here on stage. Yep. Why don't you talk to us a little bit about Information Systems Lab and what y'all are doing to advance this digital engineering revolution for radar tests?
Yeah, sure. Thanks, Hayden. ISL is a technology company focused on modeling and simulation to help engineers and service members simulate and train in a realistic digital environment. The software tool RFView pulls from classified and unclassified databases and allows engineers to simulate real, complex, real-world radar and EW scenarios and take those simulations into the real world with a full hardware-in-the-loop environment emulation using NI RF transceivers and software.
So with RFU, you can simulate almost any operational scenario and environment, kind of like a virtual reality, but for radar.
Yeah, exactly. That's right. We use RFU with the NI RF transceivers technology to really simulate the very complex world around a radar in real time. And that can include not only clutter, but also other emitters, unintentional, intentional interference. That's really a very complex environment. And this really, by using this technology, allows us to test against many more of those threats than you ever could in the open range. Basically, it allows us to fly your radar anywhere in the world, right in your lab.
Well, so we got the radar spinning here. Why don't you tell us a little bit about what's happening here with this particular setup?
Okay, yeah, thanks, Aiden. So we have over here, this is a marine radar. It's actually transmitting out, coming out through the cable into the NI-RF transceiver. It captures that pulse, convolves it with the environment that it would be seeing, which is where RFU comes in using LabVIEW FPGA, then sends it back out to the radar. So whatever the radar is seeing, I guess I actually got to start this. And so as far as the radar is concerned, it's now actually flying right off the coast of Los Angeles.
So as you can see here, this is really interesting because on the right screen, this is RFU running in LabVIEW, and you can see it's in Los Angeles. And here's the operator interface of the radar. And as you can see, the terrain data matches because of that terrain database that's running on the FPGA. And as you just saw, what just happened is it updated, downloaded a new terrain database to the FPGA, and now we're flying in lovely Yellowstone. Wonderful. It seems like we're flying this radar all over the place.
Yeah, absolutely. And as far as the radar is concerned, it really thinks it's there. And as Dr. Meyer explained, as RF systems on the battlefield become more complex, there's more emitters, interference, all sorts of things, the traditional testing methods that we've relied on over the years really limits the number of scenarios that you can test against, out in the field in the real world. But using RFU and the NI-RF transceiver technology really gives engineers the tools to test virtually in whatever scenario they can dream up and be able to do that right in their lab. And that really maximizes the mission effectiveness of these systems for the warfighter and allows them to be fielded much more quickly.
Well, I appreciate the demo, Dave. It's a really good example of how engineers are using NI technology to modernize radar tests. In addition to the NI and ISL solution, I am really excited to announce an all-new end-to-end radar test capability. This new offering today that we're announcing combines the 1 gigahertz bandwidth and the high frequencies of the vector signal transceiver with an all-new software driver that allows engineers to inject multiple independent targets into a radar for test, all in a closed-loop FPGA-based system. So a new capability for the VST. That's pretty cool.
Yeah.
What's really cool about both of these solutions for me is this is going to give those engineers the tools to increase test coverage, which is going to lead to improved confidence in system-level performance of these systems before they are then delivered to the warfighter. And as Dr. Meyer mentioned earlier, this ability to digitally test earlier is going to lead to improved operational readiness and ultimately mission success. I invite you all to stop by the Defense Expo and take a look at both of these systems up close.
Awesome. Thanks, guys.
Thank you.
Very cool.
Thank you.
You want to go to here?
Yeah, got it.
Yeah, and such another really, really important and impactful application in the world. Now, Hayden just announced one product, but one of the things we like to do here at NI Connect, of course, is announce some of the new technologies that we're bringing out to help you achieve some of these same benefits. So to talk more about some of the software products that we're launching, I'm going to kick it over to Kaitlyn Mazzarella to share about these products. So Kaitlyn.
Good morning. My name is Kaitlyn Mazzarella, and I'm an engineer at NI. I'm really excited about some of the new products we're announcing this year at NI Connect because we're focusing on giving you more holistic test solutions to help you through every step of test, from design specifications all the way through to production test. Think of it like NI giving you an entire toolbox, instead of just a hammer. This is the model that we're leaning into that's really going to help you turn your test strategy into a competitive edge. Let's start by talking about test workflow, the bundle of NI software that we introduced earlier this year that's going to give you access to all the tools you need for validation all the way through to production test. Think of it like Microsoft Office 365, but for test engineers. And with the bundle pricing, this is going to be the preferred and most cost-effective way to purchase most NI software, especially if you're already using software from NI, like LabVIEW, for example. You'll also be getting access to all the latest software updates. For example, in the next LabVIEW release, you're going to see that we're improving hooks to Python and MATLAB. We're extending OS support for Windows 11 and 64-bit, and we're also decoupling our driver versions from LabVIEW so that you're not having to upgrade your driver with every single software update. Many of these requests have come directly from the community, so know that we're listening to you. We're also working on adding new software capabilities to test workflow, like the Measurement SDK. Think of this like a template for all of your validation work, where all you need to do is build your measurement code once, use that code in interactive testing, and then reuse in your automated environments. You can also use this with your third-party instrumentation to further simplify your workflow. This is going to be huge for anybody interested in standardization, because this is really helping you to reduce the time spent coding so you can focus on the real validation work. Now, obviously, validation work is going to result in a lot of data generated from your automated tests, and we keep hearing from customers that it's extremely painful to manage this process in a way that drives action. Well, now, NI's new Data Studio is going to help you pull data from your entire connected engineering flow, which means specification all the way to production. Data Studio is going to help you ensure spec compliance, manage and analyze your data, and visualize your results in a way that'll help you to fuel intelligent decision making. So, as you can see, NI's been busy working on a ton of new tools to get you to market faster and with higher performance products. Come join our experts in these technical sessions to learn all about these products in more detail.
All right, thank you, Kaitlyn. Innovative things. You can give Kaitlyn a hand. She's out there somewhere. And you're gonna hear more from Kaitlyn in just a little bit about some of the other products that we're releasing here at NI Connect. Now, our next guest has been using NI products and systems for a long time, for a couple of decades, and he's here to share how he's using a new as-a-service offering from NI to increase the uptime of some very, very important test systems. Please welcome from Stryker Corporation, Michael Trumm. Buddy? Hi. A long time for NI Week participant, and you finally got up on stage, so welcome, Michael. So you've been working in validation tests for like 20 years, or over 20 years, and let's talk a little bit about how your career has evolved over that time and how your use of this technology in testing has evolved too.
Well, I appreciate the opportunity, Eric, thank you, and I'd be happy to. So I started working as a test engineer, and I was introduced to LabVIEW 5.0, and that's where my software journey started.
It's a good one.
Over the next decade, I continued to improve my programming skills and eventually worked my way up into using frameworks so I could deliver better test solutions faster. Well, then in 2011, while at NI Week, I was challenged to take my programming skills even further. And I started working with one of your NI Alliance partners, and we built a flexible, scalable, and modular test platform that we still use in most of our test systems today. Now, as the platform grew and our standardization efforts spread, I started working with other LabVIEW enthusiasts from across the company, and together, we established an enterprise agreement with NI. This gives all of our engineers worldwide direct access to NI's comprehensive library of software tools without having to go through a long evaluation, approval, and purchasing process for every user. Now, with the right tools in place, I started working with another NI Alliance partner, and we started providing analysis and data management services to our internal customers. And that brings us here today, where we've gone beyond just simple test automation and data collection, and now go into digitization and connected systems, so we can get the data that we need.
Yeah, it's quite a journey. And working for a $17 billion medical device manufacturer, and needless to say, validation test is really, really important, right? And so how do you use connected systems and data to meet these business goals you have?
Absolutely. Now, in my line of work, we're responsible for validating the medical device designs used to help healthcare providers save lives. And our test systems are very critical to that validation process, an absolute priority. So, when those test systems unexpectedly fail, we have to drop everything and get those systems back up and running as quickly as possible so we can minimize any delays in our already very tight release schedule.
Yeah, probably pretty resonant to folks in the audience. I assume I've heard this many times. You've got these great plans, but if a system goes down, you got to drop them, work on that, right?
Yes. Yeah, I would think so. And not to mention, test system failure can potentially compromise our test samples as well, which will even cause further delays. Now, to avoid this, we know that our test systems need to be connected. So we gathered the data to eventually predict these failures. Now, a connected system is only value added to us if it provides data that leads to timely, actionable decisions. So the first step is to understand exactly what needs to be measured, and then we can figure out how to use that data to predict the failures. In our case, with complex medical device test systems, we want to measure and use the data from critical points of operation so we can predict when the test system needs maintenance before it breaks down. Now, there are solutions out there that can predict failures on some very targeted equipment, but there really hasn't been any universal solution for monitoring and predicting test system failures for all of our test systems.
Yeah, absolutely. There's plenty of solutions for like large industrial assets, for example, for predictive maintenance, but test systems are usually more complex, and they're just as mission critical. So obviously we noticed that, and we've been working to address that gap. And today we're really excited to announce Active Uptime, which is a new maintenance as a service solution for monitoring and predictive maintenance of test assets. So Active Uptime combines software, hardware, and service into a single solution to help improve your equipment's uptime. It includes proactive monitoring of system health, an assigned support contact, and a path towards predictive maintenance using machine learning to prevent future failures. Now, Michael, you've been a lead user on Active Uptime, so tell us how it's improving the uptime of your systems.
Well, sure thing. With Active Uptime, we can monitor a test system's vital signs, and that helps us to understand the overall health and state of our test systems. It gives us the visibility we need to monitor the critical failure points, as well as other factors that can potentially impact the test system, such as temperature or humidity. Using Active Uptime, we can gather all this information together and serve it up in a dashboard. Over time, we can then be able to predict and address these failures before they become a problem by collecting all the different factors together at the times of failure. We can then train our models to see what an approaching failure will look like. And when we can predict, we can prevent. I believe this technology has the potential to all but eliminate the exception factor in our workflows. By that I mean, it can help remove the chaos and disruption that an unexpected test system failure can cause. Active Uptime gives us the ability to proactively address issues by adjusting and planning for maintenance around our test schedules before they cause expensive delays.
Yeah, and so that's the idea, is to eliminate those moments you talked about earlier. We got to drop everything and work on a tester issue using data and predictive insights. Now, what other impacts can this maintenance as a service solution have on your business?
Well, as you mentioned before, until now there really hasn't been a solution that is targeted to monitoring and predicting failures for a wide variety of test systems. Therefore, we currently must mitigate this downtime by using redundancy and spare parts to ensure that we have working test equipment when it's needed. Now, this of course adds significant cost to the business. So with Active Uptime and the insights it provides, we can right-size how many spare parts we stock. And we may even be able to reduce the total number of test systems needed to maintain the same test capacity in the future. Now, if we decide to invest in more test systems, it would be due to an increase in demand rather than to just redundancy. And that translates directly into more business. So looking forward, Active Uptime also has the potential to help us predict the remaining useful life of the test system and its components. This means we can upgrade and order parts well before they are needed, and that is especially beneficial in today's world where long lead times are the norm rather than the exception.
I've heard.
Ultimately, I foresee Active Uptime spreading out from our validation labs and into production, where predictive maintenance and system uptime is even more critical to our business. The potential for Active Uptime to provide significant value in a manufacturing environment is undeniable.
Wow, Michael, that's really cool. It's awesome that you work directly with us on this product. It's fantastic to see the impact it potentially has on your business, and thanks for sharing your whole journey. Appreciate it.
Thank you very much.
Michael, thanks. You can, by the way, you can of course check out a demo of Active Uptime and learn more about it in the Experience Lounge. So before we move on, we're going to check back in with Kaitlyn on some of the new hardware products that we're releasing today. Kaitlyn?
Hi, Hi, it's Kaitlyn again, and next I want to talk about some of our hardware innovations. First up is the PXIe 4190, which is an exciting industry first. This is a native 2-in-1 LCR meter and SMU, which also happens to be the industry's first LCR meter in a PXI form factor. This new instrument type is bringing femtofarad, which is 10 to the negative 15, and femtoamp class measurements. Basically what this means is extremely high accuracy measurements and increased throughput in a smaller form factor. PXI continues to be a very important investment area for NI, but the innovation doesn't stop there. We're also looking to disrupt the status quo for volume-optimized functional test. A modular, off-the-shelf solution in this space has never existed before, but now I'm excited to announce NI's new hardware platform, TestScale. Optimized for distributed test lines, this has been co-developed with some of the most experienced integrators from around the world. This new platform combines a lightweight USB backplane with I/O and power supply modules. We also have switching and other instruments on the roadmap. This is what it looks like. What makes TestScale revolutionary is how its size allows in-fixture designs. Why pay and make space for a rack when you can just build the instrumentation right into the fixture? In this example, built by our partner CircuitCheck, the instrumentation is mounted right to the interposer board beneath the DUT. This creates the shortest possible signal path. Our vision is that the manufacturing floor of the future will be a standardized line of fully automated and independent cells, deployed globally and managed remotely. An example of this vision comes from our partner Verma with their launch of UniLine, a scalable, universal inline platform that uses NI software and hardware. Their use of TestScale is what really makes this approach affordable for electronic device manufacturing. It provides highly customizable test coverage, optimizes development time, and reduces operational and deployment costs. Join our experts in the technical sessions to learn more about TestScale, chat with Verma about UniLine, and check out the demonstration from CCI in the Experience Lounge today.
All right, thanks again, Kaitlyn. Exciting stuff. TestScale is particularly exciting. It's an area that I've talked to many of you about in the past, a gap in sort of this type of measurement for high volume production tests and electronics. So looking forward to that. And shout out to the partners that we highlighted there, Verma, Booster, and CircuitCheck. Verma is helping us compete with those GM videos. That was pretty cool. Okay, the last speaker that we have here this morning is going to give us a glimpse of how they're using common test systems across their development flow, along with data and analytics to get some of the world's most complex semiconductors to market faster than ever before. Please welcome from Qualcomm, Gaurav Verma. Gaurav.
Thank you, Eric. Thank you for having me.
Yeah, thank you so much for joining. I mean, look, you're right in the middle of so much of the innovation that's happening in the mobile industry, innovation that we all use every day. So let's start with your perspective on the evolution of that technology and what's happening in your industry.
Absolutely, absolutely. Today we are privileged to take advantage of 5G as a consumer across the board, as a day-to-day thing. We are streaming high-definition videos real-time across the board. We are tethering our phones to get broadband internet. We have better coverage at all locations where we had never imagined it before. Innovation in wireless technology over the last 5 decades has what has made this possible. The key thing to remember is that the innovation that you see normally on a phone, better screens, better camera, perfect. However, this 5G is also driving innovation within our semiconductor industry and companies like us to be able to build, design, and manufacture chips like never before.
Yeah, and this is something I wanted to emphasize because as consumers, we all kind of take for granted this incredible technology and how it changes, but it doesn't happen by accident. It happens because engineers at Qualcomm and other companies are working relentlessly at every single step of the process to drive massive innovation. So how do you drive sort of breakthrough innovation across your product development and test teams?
I think one of the key things, one of the biggest challenges is the sheer complexity in the scope that has changed over from 3G to 5G. Over the past 5 decades, we have seen a 50x increase in throughput going from 3G to 5G. However, that same 50x throughput has caused over 500,000x increase in the number of test cases.
Which is mind-blowing.
The sheer number of cases that we have to cover, it's just unimaginable now. At the same time, 5G has also required us innovations in the measurement methodology itself. We have new millimeter wave band skin coming up with 2839 gigahertz, which require changes and innovation in the entire packaging technology. In a millimeter wave module, we have the RF front end and the antennas combined together as a part of an AIP device. We've been working extremely closely with the NI's engineering team to make sure we are able to use and utilize the over-the-air measurement techniques, which are the new requirements for AIP devices, and that has helped us to work closely with your team for the PXI solution that can help for both RF measurements and closed-loop motion control, and we have been able to increase our throughput by over 40%.
Wow.
Over the time, we have also continued to evolve the OTA solution even more. Going beyond 44 gigahertz, we have been working closely with NI as the lead user on the next generation millimeter wave technology that will allow us to actually enable it up to 54 gigahertz.
Absolutely, yeah, and you're probably seeing a theme, because it's another area where we have a lead user that we've been deliberately working with to make sure that we can get technology to market with the needs that you have in the time frame that you need it to hit these very tight market windows. And so we really appreciate, by the way, your teams work with us as a lead user. You push us on features and specifications to make sure that it can meet those needs. Now, advanced RF instrumentation is one challenge. Another is just the time horizon that you have. Can you talk about how these shorter and shorter cycles impact your organization?
I think that's a great point, actually. Teams like mine are under enormous pressure to be able to reduce the time that it takes to validate, characterize, and put the RAM to production than ever before. A decade ago, we used to have to around 24 months when we got our first engineering samples to when we were shipping our first customer samples. Even beyond that, it would take another 7 to 8 months before we ship our first 1,000,000 units. But now, the time it takes from the engineering samples to the first 1,000,000 units would be less than 6 months.
Which is incredible.
It's absolutely,
incredible, yeah.
Exactly. So now with this, we can't continue to approach tests in the same old way. We have to find new ways to be able to move from one phase of the development to another much more quickly. One of the approaches that we did working closely with NI is to standardize the hardware and the software across all of our labs. By standardizing this, we have been able to significantly reduce our RFIC characterization time. More recently, we expanded this approach to actually reuse the hardware software not just between the labs, but actually between the lab and the production environment itself. By developing a custom version of the NI's STS production test software, we have been able to reuse the test programs throughout the entire development cycle from conception to production itself.
Yeah, this is a really important milestone because this is a concept that lots of companies in this space have talked about for a long time. But not so many have achieved it. And in this case, this isn't just a vision you're describing. This is actually what you're doing today. So how did you achieve that? What did you have to overcome, and how did our teams help?
Absolutely. So one of the key decisions we made several years ago was to combine our characterization and manufacturing test teams as a part of the same organization. This has enabled us to efficiently share both the best practices and the test programs between them and significantly reduce the characterization and the correlation time. To maximize this benefit, we have been working closely with the NI's STS team so that we have a seamless software between your production to the characterization and back and forth on that.
Yeah. So throughout today, we're going to be talking about the role of data and advanced analytics to accelerate product development. How are you using these technologies today? And tell us about your vision for how you'll use them in the future.
I agree. I think data is going to be critical. Let's start with the manufacturing environment, where we must carefully balance the trade-offs between cost, quality, and yield to make sure we have the best thing going to the consumer. Today, we are using the NI's Optimal Plus analytics software to drive improvement in the product quality and also supplier management. These tools allow us to manage the data collection and analysis across our entire OSAT ecosystem. This has allowed us to benchmark one supplier versus another and make sure we are able to deliver the highest quality product at the best cost to our customers in the end. In addition, we have enabled new tools within the O+, which have allowed us to do things like outlier detection, which has significantly improved our outgoing quality. This has also enabled us to give better feedback back into the fab and the assembly process, and this will enable us to actually leverage this data to enable more AI and machine learning capabilities in the future. There's often a duplication of effort across each phase of the design process. Imagine a future state where the new device's target specifications drive the EDA simulation parameters and the test program both in the characterization lab and in manufacturing. Not only would this accelerate the time to market, but it would also improve the device models themselves in terms of simulation, and actually the future versions of product will be much better in terms of both quality and in terms of cost in the NRE that we have to spend to enable that. The idea of using AI and machine learning to integrate test capabilities with advanced analytics might seem far-fetched to many of you, or even a bit scary. However, this reality is not far away in the future. We are excited to share this vision of future of test with NI and excited to work together on making this as a reality.
That's awesome. It's really on the leading edge. And again, the application is so impactful to everyone that uses a mobile device. So thank you.
Thank you.
Gaurav, for sharing. Yeah. Very cool. So I think what you just saw there from Gaurav was a little glimpse of the future of test. And we believe that the future of test is listening to your data, understanding it, and acting on it to increase the performance of your systems and your products and ultimately your business. All of us want our products to perform better. We want to solve big problems like we saw here today. We want to be the ones that enable these incremental gains that add up to a big difference in performance. This afternoon, as I mentioned, you're going to learn about the journey to higher performance and how test plays a big role now and in the future. You'll see examples of companies that are achieving success at each stage. And hopefully you'll also hear some ideas that will push your thinking beyond what is being achieved today. I opened up talking about the British cycling team. They showed us how gathering data and analyzing it and acting on it, even on small things, can add up to a massive performance increase that put them in the top of their field. Let's all follow that example and find opportunities in our space to engineer ambitiously and push our performance higher. Thank you all for spending time with us this morning, and we look forward to seeing you back here this afternoon. Have a great NI Connect.